All right, it says we're recording. So what questions do you guys have for me? Did you guys all take the, oh, did I not post it? I posted it, didn't I? Oh yeah, it was old screen. Who took the final? The practice final?
I got through about half of it. Could we do number 17?
Oh, there it is. All right, let me start sharing. All right, number 17. All right, to get the present value, that is the principal needed, round to the nearest cent, you need $17,000, or you need $10,000 after 3 years at 6% compounded monthly. So how would you do that one?
So I used the formula, and I got 1,000 equals P parentheses 1 plus 0.06 over 12, close parentheses, the exponent of 12 times 3.
Okay, so the formula used was A equals P times 1 plus R to the nth power. No, 1 plus R over N to the NT power, right? Isn't that what you used?
Yeah.
Except for there's not a plus in there. Plus, I say. All right, so how did you plug in the numbers?
So I put 1,000 in for A.
10,000.
Or yeah, sorry, 10,000. And
1,000
then equals P and then parentheses.
P times.
Yeah, 1 plus 0.06 over 12. And then 12 times 3.
12 times 3. Okay.
So I just noticed that on the key, because I did it and I got the wrong answer, so I looked at the key, and they had made their exponent negative, and they had switched the A and the P, so the 10,000 with the P. So I was just wondering how to do that and what made the exponent negative.
Really? To find the present value, that is the principal needed around to the nearest cent. So all you need to do is divide everything on the right side, this whole thing. And so if I take equals 10,000 divided by everything else, ooh. That's weird. Let me do this again. 10,000. Oops, that's 100,000. 10,000 equals that divided by that. Oh, there we go. That's better. I don't know what happened here. I typed something wrong. Get rid of that. So it should be 31, 39, 68, basically. Is that what they got?
No, that's not what they got.
That's not what they got? Did they use a different formula? There is a present value formula, but I don't think, well, let me back up a second, because if I take that value equals 31, 39.68 times, and then if I put the rest of that in there, that should give me, I do wonder if maybe this was not correct. It should give me 10,000 back. If I type it in right.
The answer on the sheet is 8,356.
Somebody's talking super soft.
Sorry, I'm using my computer mic. Can you hear me now?
Very soft, but better.
Okay, let me plug in my headphones.
He said that the answer that they got was 8,356.
Yes.
Okay. Equals that raised to the 36th power. I think I am doing something wrong here. I thought that it would, Excel must be calculating something wrong. Okay, so let me do this. Oh, maybe I should have left it the way it was. Okay, so let's figure out what's on the right side. I've got 1 plus 0.06 divided by 12. So inside the parentheses is 1.005. If I raise that to the 36th power, I should get 1.119. Okay. I think I did I trusted that Excel would do this properly, but it didn't. So if I take $10,000 divided by that, $10,000 divided by that gives me 8356.45. That's really, is that what you said?
Yeah.
Okay, that was the right answer. My problem was, and I guess that's a problem that all of us will have, is if you type this in, I trusted that if I typed it in that way, that Excel would give me 1.119, which I think it did not. It gave me 3.18. And I think the problem was because I did not put this in parentheses. That's what the problem was. So we raised it to the 12th power and then multiplied it by 3. That's what happened. So I didn't put it. So make sure you get your parentheses right. That was a big lesson there. So yeah, that's what it should be. 8356.45.
So their method of making the exponent negative isn't what we should do.
So, well, let me just say this. Okay. So what I can do is I can devote. So this was the correct formula. I'm going to copy it over here. So now if I take the right side and if I divide both sides by that, right? So now I've got 10,000 divided by this equals P. Okay. Now, one way to write that is if I write it with negative exponents, except for there's no P here. Let me get rid of that P. If I write that with negative exponents, it's the same thing as 10,000 times everything. And then if I raise that to the negative power, negative exponent, so essentially this here is the same thing as this fraction.
Okay, yeah, that makes sense.
Okay. So that's, except for don't get rid of the P. Yeah, that's the same thing. Okay. All right, what other questions do you have?
Can we do 20?
20. Okay. Graph this function.
20.
Oh, that's 19. Thank you. Sorry, I can't read very well. All right, so let's do 20. So find the first term common difference and give it the recursive formula. So the 6th term is 31, the 14th term is negative 49. So a sub 6 equals 31, and a sub 14 equals negative 49. And since it's talking, oh, it did say it's an arithmetic sequence. So what's the formula for the arithmetic sequence? Do you remember? Do I still have that open? Okay, so let me do this really quick. You will get this formula sheet. I can't remember where I put it. Is it here? This is the formula. So can I put this next to the other thing? Okay. So you will get this formula sheet. I think that's all the formulas you're going to see. No, there's one more. Okay, so I've got the whole thing there. So which formula is useful for this?
Would it be the S of n equals
so we're
1 divided by 2?
no, because we're not looking for a sum on this one.
So then it would be the a sub n equals a
Yeah.
plus, okay.
Yeah, that first one there. Okay. So that's the formula we're going to use. And so we don't know what a sub 1 is. I'm just going to put a for a sub 1. Plus, we know what n is. What's n in this first case?
Six.
6 minus 1. And we don't know our difference, d. Okay, we're going to use the exact same formula again, except for my n has changed. It's no longer 6, it is
14.
right? Okay. So, so this simplifies to a plus 5d equals 31, and this equals a plus 13d equals negative 49. So do you know how to solve it from there?
Wouldn't you just do elimination?
Elimination, we can eliminate the a's by subtracting. So 5 minus 13 is?
Negative 8.
Negative 8d equals 31 minus 49. So that's going to be 80. So d equals what?
10.
Negative 10. Right? Okay, so if d equals negative 10, then I can put it into either one of these equations here, or these ones here. That's probably easier. So that gives me a plus 5 times negative 10 equals 31. So if I add 50 to both sides, then a equals, or a sub 1 equals what?
81.
81. Okay. All right. So find the first term. First term is 81. Find the common difference. D is negative 10. Find a recursive formula for the sequence. So what is the recursive formula? I think you guys all missed this one on the last test too.
Would you use the a sub n equals a sub 1 times r to the exponent of n minus 1?
No, because that's for a geometric series. And this is arithmetic. So let me ask it this way. If the common difference is -10, what do you do? So, and we know that, so we know, let me do it this way. We know what a sub 1 is, right? A sub 1 is 81. What is a sub 2?
71.
71. And a sub 3?
61.
61. Seen a pattern? What's the pattern?
-10.
We're subtracting 10 every time, right? So the recursive formula is to say a sub n equals the previous term, a sub n minus 1. And then what are we doing every time?
Subtracting 10.
Subtracting 10. So that's, pretend those are subscripts, a sub n and a sub n minus 1. That's your recursive formula. Does that make sense? Or to make this better, I'll draw with my finger a sub n equals a sub n minus 1 minus 10. That's the answer. Okay?
Why is it a sub n minus 1?
Because a sub n minus 1 represents the previous term. Okay? So if you're on a sub 2, a sub 2 says take the last term, which was a sub 1, and subtract 10.
Okay.
So you're just going to subtract 10 every time. Subtract 10 every time. That's all you're doing. The next one's going to be 51, and 41, and 31, and 21, etc. You're just subtracting 10 every time. So that's what this part is here. You're subtracting 10 from whatever the previous term is. So if this is a sub 2, the previous term is a sub 1. If this is a sub 3, the previous term is a sub 2. A sub 4, the previous term is a sub 3. Does that make sense?
Yeah.
Okay. All right. What else you got? It's funny because this is my statistics class here. That is. And I said, oh, let me close all my college algebra stuff. And then I left all this open. It's part of my statistics too.
Can we do 23?
23. Given that the real zero below is x equals 1, find all of the real zeros. Okay. Well, that was nice of them to give you an answer. I wouldn't give you any answers. Here we go. How do we do that? I can't copy for anything. Okay, so f of x equals x cubed minus 5x squared plus 5x minus 1. And they were nice and told you that x equals 1 is one of the zeros. So what do we do with that?
I'm not quite sure.
Okay, anybody have any ideas?
Do you
Michael
go P's and
knows.
Q's?
We could do P's and Q's, and that's what, and under normal circumstances, that's what I would do. But they told you, that 1 was an answer.
So you can do synthetic division and simplify the equation, basically.
Exactly. So I know that 1 is an answer, so that actually even before I do my P's and Q's is helpful. So the coefficients are
1, -5, 5, and -1.
okay. So here I'm just going to box this so it looks like it. Okay, so 1 plus 0 is 1. Do you guys remember how to do synthetic division? Does Andrew remember?
Yeah.
Okay, what do I do next?
Times by 1, so it's just going to be 1
Okay,
again. It's a -4.
okay,
And then it's going to be -4. And then 1. And then 1 again. And 0.
okay. All right, so if x equals 1 is a 0, then this factors into what?
Is it x squared
So x minus 1, I'm going to leave that up front. And then you've got your x squared
minus 4x
minus 4x
plus 1?
plus 1. So that was real nice of them to give you one of the zeros because then you didn't need to figure out your P's and Q's, okay? So now the question is this factorable? Is this here factorable?
No.
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 So what happens when you do when it's not factorable?
Quadratic formula.
There we go. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. All right, so who can help me plug this in the quadratic formula besides Michael?
I'll do it.
Okay,
So it's gonna be negative b, so it's gonna be -4, which is will really be a +4,
so negative 4 is a positive 4, okay?
plus or minus square root -4 squared minus
Which is 16 minus,
-4 times 1 times 1 all over 2 times 1.
all over 2 times 1, which is just 2, okay? So I've got 4 plus or minus the square root, I said 4, not r, plus or minus the square root of 16 minus 4, which is 12, all over 2. Can I do any more simplifying?
3 times 4 is 12, so you could do 2 root 3.
So 4 plus or minus 2 times the square root of 3 all over 2. And now my 2 cancels with my 2 and my 4, right?
Mm-hmm.
So I'm left with 2 plus or minus the square root of 3. Okay? So remember it's a degree 3 function, so I've got 1 at 1, and I've got 1 at 2 plus the square root of 3 and 2 minus the square root of 3. So I found all 3 solutions. So those are your zeros. Okay? It's a good one. Clearing out the cobwebs. Who's still got cobwebs? Nobody
That's
wants
cleared
to
them
admit it. Okay. All right. So what next?
Can we do a problem with imaginary numbers?
Sure, but my imagination's not very good. Do you know one? Or I can make up one. I guess I could. We'll do the opposite. So I'll just make up one. So let's say that I want you to find a polynomial function of degree 3 with zeros at 3 and 1 plus I. How would you do that?
You know that x minus 3 is one of the zeros.
Okay, x minus 3 is one of the zeros.
One of the zeros is x minus 1 plus I.
And I'm going to put these in parentheses because I always screw it up if I don't. And
x minus 1 minus I.
okay. So let's worry about our imaginary numbers first. So this becomes x minus 3. I'm going to just put this x minus 3 here. I'm going to ignore it for just a minute. And I'm going to have x minus 1 minus I. And I'm going to have x minus 1 plus I. Okay. Now let's take and FOIL these two together. Okay. So x times x is x squared. X times negative 1 is negative x. X times I is xi. You know what? I'm going to do this differently. I'm going to do this as x squared. I'm going to have a negative x. I'm going to have an ix. Okay, I'm going to put these in columns. This is a good thing to do. I think it'll help you keep yourself straight. Okay, so I just multiplied the x times all three of those. Now I need to do the negative 1. So negative 1 times x is negative x. Negative 1 times negative 1 is 1. And negative 1 times I is negative I. Negative I. Okay. Now we're going to do the last one, the negative I times all of those. So negative I times x is negative ix. Negative I times negative I is negative I squared. And negative I, oh, I forgot the negative 1. I missed that one. Negative I times negative 1 is positive I. Okay. All right, so I'm going to add down. So I've got x squared. Okay. I've got minus 2x. Okay. These are going to cancel. They're done. They cancel with each other. I'm going to have a plus 1. These are also going to cancel. And I'm going to have negative I squared. Now, what is I squared?
Is it 1 or is it negative 1?
Yeah, you tell me.
Is it 1?
No, it's negative 1.
Yeah, 1. Okay.
So we're subtracting negative 1.
So you're going to add.
So we're going to add another one. So since I've already got a 1, I got a 1 from this one, and I got a 1 from that I squared. So that becomes 2. So this is a polynomial function P of x equals x squared minus 2x plus 2. Okay. All right, what other questions do you guys have?
Can we do 25?
25. Half of plutonium-234 is 9 hours, the half-life. How much will be present in 15 hours? Okay. So how do we do this one?
I'm
Any
not sure.
ideas?
I'm not sure what formula they want us to use.
Okay. Will our formula sheet help us at all? Oh, it won't. Okay, so there's a formula they want you to remember. What's the formula they want you to remember?
I'm not sure.
Okay. Anybody remember? Michael remembers.
Half-life? I don't remember that.
Don't remember that one? How about A equals PERT?
Right.
Okay. A equals PE to the RT. Okay, of course we know what E is. Now half-life is an important part of this, right? So if we started with, so P is your principal. So we started with, well, it says 90 milligrams. So if we started in 90 milligrams, how much will we have in 9 hours?
45? Or are you doubling it or halving it?
It says half-life, so we're going to half it.
Okay,
So 45 equals your 90. We started with 90 milligrams. E is that number raised to the, what's your rate?
Hmm.
Nine.
Nope, that's your time.
Isn't it 1/2?
Is it 0.5?
Nope. I'm waiting for somebody to say, I don't know, and I would say, that's the correct answer. We don't know what our rate is.
Okay.
E, but our time is 9 hours, okay? So now we can solve this for the rate. So if I divide both sides by 90, 45 divided by 90 is 1/2, or I'm going to put 0.5 there, but 1/2 is fine. 1/2 is going to equal E raised to the 9R. And how do we solve this for R?
Take the natural log.
Very good. So the ln of 0.5 equals 9R, right? And divide both sides by 9. All right, so then I'm going to get the rate equals the ln of 0.5 divided by 9, and we can use that rate equals the ln of 0.5 divided by 9. So your rate is going to be negative 0.077. Now, is it okay that it's negative?
Yeah.
Yeah, because it's decaying. We're glad our money doesn't decay. All right, but it's okay with the half-life. Okay, so now we want to know how much is in 15 hours. So really, this is A as a function of t equals that, okay? So we want to find A of 15. So how do we find that?
You're gonna, is it still the like per equation, but it's a of 15?
Correct.
So,
So what do I put in for P?
still 90.
Still 90. E raised to the
Negative 0.07702
times
15.
15. That's correct. Okay. And so when we plug this in our calculator, we're going to get 90 times E and I'm going to use the actual number instead of rounding it, times 15. That's correct. Yeah. So you're going to have 28.3. It says round to 4 decimal places. So actually, that's 5. Close enough. 28.43482 grams. Milligrams, whatever, mg. Okay. Make sense?
Yes, thank you.
Okay. So don't forget A equals PERT. All right, what else do you have? By the way, do you like all my bell curves over here? That was pretty good. That was my stats class.
Can we do a problem with Newton's law of cooling?
Do we have one on here? We can. I'm going to be really surprised if did they give one on the review?
I don't think so.
I don't think so either. I would be surprised if that's on there. And if they do, we can do it. I just, see, is that must be on my review then. Is it on my review?
I think they do give one on the.
Oh, they did?
I could be
Okay.
wrong, but
We can do it. I'm happy to do it. I would still be surprised if they put one on there. But we can do it. I might be wrong. If I can find, am I in the right place? I am. There we go. Actually, I've got it right here. What was I thinking? Okay, Newton's law. Let me see. I'll just do a search for Newton. Oh, they don't have one.
this question is asking you to find the temperature of the engine 20 minutes after being turned off. I don't know if that would be a cooling question.
Oh, it's close. It's not Newton's law of cooling, but it's close enough. Yeah, this one's not quite Newton's law of tuning. Okay, so that's the formula that you're going to use. They were nice and gave it to you, which I don't know how you would have figured it out if they didn't give it to you. So on a cold winter day, the temperature T of a car engine, little case t minutes after being turned off is given by this equation. Find the temperature after 20 minutes. So what do you think? Did I miss anything? On a cold winter day, temperature T of a car engine 10 minutes after turn off is given by that. Find the temperature of the engine 20 minutes after being turned off. Okay, what do you think? Any ideas?
Well, you know that oh, sorry.
No, you can go.
No, well, the lowercase t is equal to 20. So
Right.
you know that one part of the other part of the equation is negative 2.2.
Right. So we got the ln of capital T minus 20 divided by 200, although the 200s are in the parentheses, which is hard to do on my thing, equals negative 0.11 times 20 minutes, which I think, is that going to tell me the answer? It did. It's 2.2. Okay. So now how do we solve? And remember that 200 is within the parentheses. So how do we solve this equation now?
Would you take the e to get rid of the ln?
Exactly right. So if I exponentiate both sides, I'm going to have my t minus 20 over my 200. Now I can make that a real fraction. And that's going to equals e raised to the negative 2.2 power. Okay. And now what?
Should we multiply each side by 200?
Yep. So t minus 20 equals 200 e to the minus 2.2. And then
Add 20 to each side.
so my capital T is 200 e to the, actually exp, I'm going to do that. We're going to get the answer right here, negative 2.2, and then we're going to add 20. Okay, drum roll please for the answer. Oh, why didn't that work? I forgot my times. Oh, that doesn't seem right. 20 degrees. Oh, I guess maybe it is. This is a cold winter day. Yeah. Does that seem right? I guess it is. $42 degrees. That's the right answer. Yeah, that's right. That's colder than I would have expected, but it says it was a cold winter day. Okay. All right, any other questions? I guess we're about out of time, aren't we? All right, so just as a reminder, test is Monday if you take it between the hours of 11 to 1. Now that's an hour sooner than normal. 11 to 1, 2-hour test. I will give you an extra 5% extra credit if you upload it by 11. Technically, these are only supposed to be an hour and 50 minutes, but I'm going to give you the full 2 hours. And oh, do you want another practice test for the weekend?
You can upload one if you want. I think that would be helpful.
Okay. All right, it'll be another Salt Lake Community College one, but yeah. So I will upload that, and I want you all to stay healthy. Number 1. Number 2, I want you to ace my final, kick butt on it, and number 3, have a great summer.
Thank you.
You're welcome.
Thank you.
Have a good
Thank
one.
you.
I'll miss your ugly shirts, Andrew. I just want you to know.
Thank you.
I meant to wear one today. It's the last day.
Oh, what were you thinking? I got my red shirt on and everything. Although it's not a Utah shirt, but it's still red.
I'll allow that hat to count. In the background.
Have a good one.
Yeah, you
Oh,
too.
by the way, let's stay on it. I got to mention
Okay.
one more thing, but I'm going to stop recording.